Well, believe it or not, we got one primary topic left in chapter 19, and that is electrolytic cells. So far, we've dealt with mostly galvanic things. Even if we ended up with something that had a negative cell potential, we kind of lump all those things together in the same type of calculating. Electrolytic cells are different than galvanic. Electrolytic cells are not spontaneous. So they have E zeros that are less than 0.0 volts, whether it's spontaneous or not spontaneous, whether it's standard conditions or not. So if we write out a cell and we calculate E0 for the cell and E0 is negative, we can still do the reaction, but we have to supply the energy. So we have to hook it up to a battery or a power supply that will make it happen. So now we go back to the idea of your cell phones, and when you plug them into the wall charger supplies the juice to run the reaction backwards that your battery uses to power it when it's not plugged into the wall. So electrolytic processes can happen, but they're just not spontaneous. There has to be energy supplied. It's an endothermic process. Energy has to be supplied to cause it to occur. And so all of your rechargeable batteries work like this, whether it's in your cell phone or your laptop or the AA, AAA rechargeables that you can buy at Walmart. So from a more scientific, like a more old school scientific point of view, you can buy metal samples that are very, very pure, and it's not uncommon for them to be electrolytically generated. And so when you take a metal solution and you push electricity into it, force that metal to reduce, you get very pure metals, very nice crystals of the metal, and it happens because you've supplied the energy to make it happen. So for example, let's say we have a beaker, and inside this beaker, we have, it's going to be hot, it's liquid sodium chloride. So we have molten sodium chloride. The old school term for that is fused. Fused is a term that means molten. It doesn't seem like it would, but it does. Fused sodium chloride is liquid sodium chloride. So it's a liquid. Duh. Okay, now into this cell here, we're going to take two wires. And we're going to hook up to a battery. Or a power supply, plug it into the wall, whatever you want to think. But it's a power supply. And we're going to force electrons to go this direction, the way they normally are supposed to go in a cell. But this is a non-spontaneous one, so the electrons want to go to the left. So we hooked this battery up, plus to the left, minus to the right. Hooked it up backwards from our normal galvanic processes, right? Galvanic process, the negative lead was from the left, the positive was from the right. So the battery reverses that polarity and forces the electrons to go the direction they don't want to go. So on the anode side, during this process, when we supply enough potential, we generate chlorine gas. So 2Cl minus goes to Cl2 plus 2 electrons. Okay? We force the electrons to come out of that side and move over to the other side. Well, the other side over here is the reduction of sodium. And as we supply potential to this, and this would be a big battery or a big power supply, we'll liberate chlorine gas from this electrode as the oxidation occurs. This electrode will grow sodium on it, sodium metal. And when they do this on an industrial scale, they'll put a sacrificial piece of sodium in to start it. The sodium grows on it, and they just slowly pull that electrode out over time, and a column of sodium is pulled up along with it. So this is how they electrolytically generate metals. So they take a solution of it or melt the solid, one or the other, and supply the energy to force something that does not want to be reduced, and force something that doesn't want to be oxidized to be oxidized. If you look up the E0 for this process, it is not favorable. But the battery overcomes that non-spontaneous character and forces it to occur, and you can do this with lots of different metals, not just any one of them, but lots of different metals can be electrolytically generated from their salts. Okay? Now that's one view of electrolysis or electrolytic cells. It's more of a conceptual view of it. The calculating part that we're going to do is determining, say, how many grams of sodium could you generate if so much current was supplied for so many minutes or hours or days or whatever. And that's where we're headed with our next video or two, is stoichiometry and electrolytic processes.